All right, the 8x8. Figured I'd give you guys a little more detail about how I did this thing because I know a bunch of you are gonna be getting yours here pretty soon. So my main goal with this thing was to run this, build this monster here without using any of the standard pass-through axles. Transmission is designed with the 13, almost 14 to 1 reduction there. Should work pretty well with most axle combinations. You'll have to do a little bit of math there, figure out your battery power or whatnot. So I'm running 4S power through these 2000 kV motors because I'm running portal axles, and the axles themselves have a lot more reduction. So I'm running like 75 to 1 reduction in axle 1 and over 100 to 1 in the fourth axle. The second and third axles are both stock ratios. My front axle has 25% overdrive in the portals, and the rear axle has a 10% underdrive in the ring and pinion. So I've got 3 different gear ratios going on there. The axles I chose, the Capras, I use those on most of my other rigs. I've got a class 2, class 3. I've run a baby Capra and mini, mini class. So I had a bunch of these extra housings and internals laying around, so I figured I might as well use them. What I've done is kind of started from the center and worked my way out. I knew I wanted these motors. I had a number of gears on hand. I geared it lower than the portal trans and not quite as high as the NOD trans, I guess. So these are 2000 kV 380 revolvers. I've got a dual suppressor ESC, the same reflash iFlight ESCs that I build for Deluxe. I actually stack 2 of them together. Same way I do it for pro rigs and for super class rigs. So what I did was I started there in the center. I knew I wanted this equipment here, and then I had to place my axles accordingly. My comp rigs, I run 12.5 inch wheelbase, but I didn't want that much room between the tires. I wanted it to do breakovers a little bit better, knowing I'd have a lot of traction, a lot of tires on the ground. So I actually reduced the distance between the second and third axles, less than what I have on my comp rigs. We are approximately about 11.25 inch, 11.5 or so between axles 2 and 3. I knew I wanted these tires because I had a bunch of these laying around already. These are G-Made Bighorn tires. They come stock in the G-Made R1. So I took the measurement of 5.3 inch tall tire. I added a 1/2 inch between them. So these axles are spaced approximately 5 3/4 inches apart. If you're running a shorter tire, you can get these closer together. You can move your front axle back a little bit. If you are running your second and third axles closer together, then it's going to free you up a little bit of room right here. But I kind of started knowing that I wanted this distance here, right about where it is, and then just had to move the first and the last axles out to clear everything. And I had to make sure that there would be no binding and no interference in the tires during any kind of articulation. So that's something that needs to be taken into account. The carrier bearings just started off as a simple brace that went across there. Holds a titanium 5mm shaft with 2 bearings in it, pretty simple. It also works as my shock mounting position there, both front and rear. This one here is a special one I've got mocked up for the rear. I had just another aluminum brace like this across the fourth shock tower. If you buy the whole kit from me, the transmission, the skid plate, the sliders, the battery tray, this carrier bearing will just be this single piece that you see right here. I've got a slimmer version. I've got another version that has the shaft going through the center. I got a couple different options for you if you need. This one here is designed, this is gonna be my trailer hitch point. So I'm gonna use an 8mm deluxe fab stub shaft through there to connect to the trailer or the wagon, as I've done so far. So my link mounting positions here were the next things I considered. This skid plate is nice and long. This belly area is nice and long, so I utilized the entire length of it. These two holes here that you see, they're your standard 38mm spacing. I had to get the transmission back a little bit further for this clearance right here between the motor and the chassis side plate. If you wanted the shorter version of the skid plate, transmission would sit further forward. You would have to run a stubby revolver or clearance the upper link mounts for the second axle there. But everything fit in there pretty well, pretty much exactly what I had envisioned with this longer skid plate. So because of that, it kind of, in a way, shortened my lower links of the second and third axles, because normally they would be attached back here. What it did for me though, how it helped me, was it made the upper and lower link mounts fairly equal. So that helps with being able to judge what exactly the axle is gonna do. The axle is gonna stay pretty level throughout its entire range of motion. So I took this general layout of the upper and the lower, and I kind of sort of duplicated that right here. Axle 1 is using the rearmost holes, keeping that same kind of layout, and axle 4 is using almost the frontmost holes, trying to keep the upper and lower links as consistent as I could, so there wasn't any goofy clocking of the axles during articulation, during range of motion. The spacing of the axles here, both front and rear, is exactly the same at 5 3/4 inches, and I've duplicated that in the shock mounting locations here at 5 3/4 inches. So if you're running your axles a little bit closer together, maybe for 4.75-inch tall tires, you could also move the shocks a little bit closer together. I have not accounted for that because that was just never my intention, but it is an option. The transmission, like I said a number of times, is 2 different gear sets. There are 8 outputs. There are 4 in the front, 4 in the rear. Each motor runs its own pair of shafts. So you can see these 2 spinning here. This motor is actually driving the front axles through these 2 shafts. This motor here is driving the rear axles through these 2. They spin independent of each other because I've got 2 different speed controls, and those gears don't mesh, so I can actually drive it like a pro rig or like a super with dig and burn. So it'll pretty much do anything I want it to do. The battery tray I've designed is based around these big hard packs that I have laying around from other stuff. Once again, it braces the front shock towers. The rear shock towers has the pass-through, the carrier bearing there. You can run a single pack flat, laid down in there if you want to keep your weight low, if you're not worried about your battery capacity. Or like me, I'm actually standing them up, running 2 of them in there side by side. This lets me run two 2S packs through a serial adapter for 4S power. I also have another adapter. I can run them in parallel if I just want 2S power. But this here gets me around 7 mile per hour top speed, With different axles, that's going to vary. So if you're running something like straight axles, AR45s, 44s, whatever, you may be better off on 3S or even 2S power, because otherwise you might be going, you might have pretty high top speed. My goal with this was to give me top speed that would pretty much match my jogging speed, comfortable jogging speed. One of the events I plan on running it in is a kind of an endurance race, 2-3 mile long race, and I'm just gonna jog it out with this thing right next to me. I have trimmed off one mounting hole off the front of my chassis there to try and fit a bumper I had laying around. And this was a chassis I had cut out of aluminum. So this would be slightly different than everybody else. The pass-throughs for the axles. This brace here could be flipped around, spun around, so you could run these two outputs up and through. You can adjust the link for the front to the opposite side if you wanted a mirrored version of the battery tray. I could do that as well. A couple things to look out for is the front drive shaft and how it's going to, where it's going to connect to your axle housings. Capras have a fairly wide spacing for the upper links. They're as wide as the servo is here. So if you got something like an AR44 where they're close together, you're gonna have to pay attention to drive shaft for axles 1 and 4 to not interfere with that upper link mount as it passes through in there. All these are standard length Deluxe Fab drive shafts. They all had to be cut down. No need for the extra long ones. Just not necessary, because they're just all close enough that the standard length ones fit. I've got a little bit of brass on my front axle, and I'm probably gonna add more brass on the other axles just to give me better towing capabilities. You can see how you don't need a heck of a lot of triangulation with your links there. It all works pretty well, even with the lower links being fairly parallel. Not a lot of movement, but that's going to be something to consider. I am using rod ends here with spacers to just give me a little clearance there, and adds a little triangulation. Just on my lowers only, I believe. One of the reasons why I chose these axles and the pass-through, or the carrier bearings, because I didn't want to mess with having to try and pass through these axles. That causes a number of other problems with clearance with your drag link or your tie rod, and going from the 3rd to 4th axle, from the 1st to 2nd axle. These are all Deluxe shocks, 96mm shorts with the offset caps. You could probably run 80mm shocks since they're about the same overall length. You'll have slightly limited travel that way though. This is almost the exact same setup I run on my comp rigs, both sporty and my class 2 rigs. So I just tried to keep everything as similar as I could. I am running, in case anybody's wondering, a Radiolink RC6 GS V3 radio. Comes with a 7-channel receiver there. I've got channels 1 and 3 doing steering. 1 is the front, 3 does the rear axles. Channel 2 and 4 are my throttle. my front and rear ESCs. Channels 5 and 6 are reserved for front and rear winches, and channel 7 is the input from my BEC. I'm running a 10 or 15 amp Castle BEC, whatever I had laying around, with these cheap Amazon servos, because I have not upgraded to decent direct power servos yet. These are just some Amazon bead locks. I already had a set of them, so I ordered a second set to match. And that's about it. If y'all got any questions about it, send me a message, tag me in a message, whatever. Be happy to help you out. If you need help figuring out link lengths, I've got plenty of axles on hand. I could pretty much mock anything up for you. It's important to know how far apart you want your axles spaced, though. That'll depend on your tire size and what you're trying to, what kind of look you're trying to get out of it. I wasn't going for any sort of scale trail truck type look. I wanted this to be really exaggerated and kind of cartoonish. And I think I got it. So if y'all have any questions, need any more information, shoot me a message. I'll try and help you out as much as I can. Thanks.